Here's another question where we need to find the reducing and oxidizing agents. The equation is given in front of you, and you need to find the oxidation states of all the elements over here. So let's start with IO3 minus 1, where you have oxygen has an oxidation state of minus 2. And since there are 3 of them, so it would be minus 2 into 3. And iodine, since iodine would have an oxidation state of minus 1, but since it is bonded with oxygen, we're not sure what the oxidation state of iodine over here is. So it's going to be X, and the total charge on this entire ion is minus 1. So if we calculate for iodine, X would be equal to, it would equal plus 5. So the oxidation state of iodine is plus 5. Over here we know the oxidation state of hydrogen is plus 1, and since there are 3 of them, we will multiply it by 3. And the oxidation state of phosphorus is unknown, so that would be X. And if we total that out, there's no charge on this entire molecule, so this should equal 0. So X over here would be minus 3. So the charge on phosphorus is minus 3. On hydrogen is plus 1. On iodine it's plus 5, and oxygen it's minus 2. And over here iodine has an oxidation state of minus 1 because there's only one iodine, and the total charge on that is minus 1. Phosphorus is existing as a pure element, so that would have an oxidation state of 0 in this case. And hydrogen over here has an oxidation state of plus 1. We already know that. And oxygen would have an oxidation state of minus 2. Now if you look at this entire molecule, entire equation, you would find out that the oxidation state of iodine is going from plus 5 over here in the iodate ion to minus 1. So this is definitely getting reduced. So and the oxidation state of phosphorus is minus 3 over here, and it's going to 0. So phosphorus is going from minus 3 to phosphorus 0. So it is getting, the oxidation state is increasing, so this is getting oxidized. And if iodine is getting reduced, so IO3 minus 1 is definitely the oxidizing agent in this case. And on the other hand, if pH3 is the phosphorus in pH3 is getting reduced, then it's actually getting, for the phosphorus in pH3 is getting oxidized. So this must be the reducing agent in this entire equation. I will be doing one last example on disproportionation, and this is a term that is applied when the same species gets oxidized and reduced. And I will show how that happens by taking an example. For example, you have bromine, and it is getting converted into BrO3 minus 1 and Br minus 1. So this is a balanced equation. It's not really a balanced equation, but bromine is getting converted into BrO3 minus 1, and it's also getting converted into Br minus 1. And if we find the oxidation states of bromine, it will be 0 in this case because bromine is existing on its own, and it has no net charge, so it's 0. Over here we don't know what the oxidation state of bromine is. It would have been minus 1, except that it is now bonded with oxygen, so we need to find the oxidation state of bromine, so that's X. And on oxygen, the oxidation state of oxygen is going to be minus 2, but it would be multiplied by 3, and the total charge on this entire ion is minus 1, so this all must add up to minus 1, so X comes out to be plus 5. So the oxidation state of bromine over here is plus 5, and on oxygen it is minus 2, and over here bromine has an oxidation state of minus 1. So you can see that bromine is going from 0, where it had an oxidation state of 0, to Br plus 5. So that is oxidation. But on the other hand, the same bromine which was 0 over here is also going to minus 1, which is reduction. So you can see the same species getting oxidized and reduced in this equation. And this is very common, so you need to be careful that this is also a possibility that the same species might get reduced and oxidized. We can think of another equation where you have, let's say, there's another equation where I'll be showing you how uh, a disproportionation reaction is happening. N2O is getting converted into N2H4 and NO3 minus 1. So if you look at the oxidation state of nitrogen over here, it's unknown, so that is X into 2 because there are two nitrogens. On oxygen it is minus 2, and that should all add up to 0, so X comes out to be 1. So the oxidation state of nitrogen over here is plus 1, and on oxygen it is minus 2. Over here you have two nitrogens again, so we don't know what that the oxidation state of nitrogen is. So that is X multiplied by 2 because there are two of them, and H is plus 1 multiplied by 4, and that should all add up to 0 because it has no net charge. So over here X comes out to be, it comes out to be minus 2. So nitrogen is minus 2 over here, hydrogen is plus 1 over here, and over here in NO3 minus 1, let's nitrogen again is X, and there are 3 oxygens, so it's 3 into minus 2, and the net charge is minus 1, so X comes out to be, it comes out to be plus 5. So nitrogen is plus 5 over here, and oxygen is minus 2 over here. So if you carefully observe this equation, nitrogen again is going from, it was plus 1 over here, so it's plus 1, and it is going to minus 2 over here. So it is getting reduced. But the same nitrogen, which is plus 1 over here, is also getting converted into N plus 5, which is an example of oxidation because the oxidation state is increasing. So these two examples of disproportionation reactions. Now from now on, in the next lectures, we're going to study how to balance redox reaction and what's the problem in encountering equations when we are trying to balance redox reactions.